Hello and welcome to another ramble with Miss T. We are looking at IEB's November 2023 paper 2, question 9b. Right, first part asks us to prove an identity. Sine theta times tan theta divided by tan of 2 theta times 1 minus tan squared theta is equal to sine theta over 2. Okay, so for me, obviously, hey, I say obviously and then it might turn out, hey, my obvious intuition was very off the mark. But anyway, the left hand side seems more complex, so that is what I'm drawn to try and break down a bit. And the left hand side has just got sine, up in there. So that makes me feel like all these references to tan have got to go. So I am going to just look at the numerator first. So tan theta is the same as sine theta over cos theta. Okay, so therefore sine theta times tan theta will be equal to sine theta times sine theta over cos theta, so that will be sine squared theta over cos theta. And I want to keep as many references to sine as possible because of this guy, so I'm just going to leave it at that for now. The bottom, let's see, so we have tan 2 theta, okay, which we can write as sine 2 theta over cos 2 theta, and obviously we can use our double angle identities to write those in terms of theta. But I first want to see what this simplifies to, because maybe it will guide what I need to do over here, because especially with this cos 2 theta, there are 3 different ways that we can express it in terms of theta. So knowing what this simplifies to could help me decide which one to use. So let me figure that out. So 1 minus tan squared theta, I will also write this as sine squared theta over cos squared theta, and then I will express this as one fraction, so that will be cos squared theta over cos squared theta, right? That's the 1 minus sine squared theta. I am seeing a vision. So that will be cos squared theta minus sine squared theta at the top, and at the bottom we have cos squared theta, and the top, ding ding ding, is the same as cos 2 theta, or cos of 2 theta. Right, so tan of 2 theta times 1 minus tan squared theta is then just the same as sine of 2 theta over cos of 2 theta, right, this guy, times this guy, cos of 2 theta divided by cos squared theta. Okay, so these guys will cancel out. So we then have sine of 2 theta divided by cos squared theta. And let's see what's going on here. So now we have this fraction, right, which is the top, divided by this fraction, which is the bottom. So we shall say left hand side, which is, oh golly wolly, the upping and downing, it's going to break my soul potentially. Okay, and at the bottom we have this, which is okay, yeah, I'm just rewriting, yeah, whatever. start by rewriting. Okay, and obviously in your exam, please write, each step on a new line. Me, I am constrained for space, so I'm just going to break the rules. So this simplified to this, sine squared theta over cos theta, sine squared theta over cos theta. Okay, and we are dividing it by this guy, which is what this simplified to. So divide by sine of 2 theta divided by, well, yeah, there's a whole lot of fractions, dividing fractions, and of course we know dividing by a fraction is just the same as multiplying by the inverse. So that'll be cos squared theta, and here we'll have sine of 2 theta. Okay, and this goes in itself once and goes in here. Remember, cos squared theta is just the same as cos theta times cos theta, so we'll just be left with cos theta up here. Okay, and then remember we're working towards sine theta over 2, so we want to cancel a bit more. So I am going to rewrite this in terms of theta instead of 2 theta. So that'll be sine squared theta, and I'm just going to make it a bit clearer for the cancelling that's going to happen soon. So that is sine theta times cos theta, right, at the top. And at the bottom, we rewrite this as 2 sine theta cos theta. Ha! So cos theta and cos theta cancel out, and sine theta also cancel out. And what are we left with? Sine theta over 2, which is the right hand side. Okay, right. So we are asked, determine the general solution for the values of theta for which the identity is not valid. Write your answer as one single statement. Okay, so yeah, it won't be valid if this denominator is equal to 0. It also won't be valid wherever tan isn't valid. So I'm just going to first solve the case where this is equal to 0 and see if that will also, it'll probably also cover the cases where tan is not defined. Remember, tan has all those asymptotes here. So let's see. So we want to figure out where tan 2 theta times 1 minus tan squared, what, theta, right, that was it, is equal to 0, because we can't, a fraction can't have 0 at the bottom. And one way we could look at this is to say, well, this simplifies to this, so we can say, well, where is this not defined? So sine has no problems, it's defined everywhere for whatever value, real value of theta, but where we would have a problem is where this is 0, because you don't want to divide by 0. So where is cos squared theta equal to 0? Or in other words, where is cos theta equal to 0? And if you think about your cos graph, that is, all your x-intercepts, so 90, 270, so pretty much anything 90 plus 180, many 180s, 180k, right? But we can also, maybe in case you've, so maybe let me write down the first approach, because that one is short. So this is the same as us looking at where is this equal to 0. So where is sine 2 theta divided by cos squared theta equal to 0, which is really looking at what? is so different to what I was saying. Where is sine 2 theta equal to 0? So sine theta, is it really different? It is kind of different. It is very different to what I was saying. So I feel like I kind of have to take back what I was saying. Wow. Well, what I was saying is still valid because, okay, because if this is 0, then this becomes undefined, then this becomes undefined. And we can't divide by undefined, right? We can't have an undefined down here. Oops. But at the same time, we also need to consider where this is equal to 0, this expression is equal to 0, which is where this is equal to 0, and the only way that this is equal to 0 is if this is equal to 0. So we'd have to look at where this is 0. So we're looking at two things. We're looking at where this is 0, because this would make this fraction undefined, which would make this undefined, which would make this undefined. So that's the one thing we're looking at. Then the other thing we're looking at is where this is equal to 0, because if this is equal to 0, then this is equal to 0, and this is equal to 0, and we would then be dividing by 0 over here, and this would be undefined. So it's actually two cases we're looking at. So let's look at it both ways. So I want to say this in two ways. Okay, so we have shown that tan warawa is equal to this. Okay, so two cases that we are concerned with is the case where, so case 1 is where cos squared theta is equal to 0, because then, just write this in pencil, because then sine 2 theta over cos squared theta is undefined, right, which would make this guy undefined, which would make the whole of the left-hand side expression and the identity in general undefined. So that's the first case we're concerned with. Then the second case we're concerned with, case 2, is the case where sine 2 theta is equal to 0, because then sine 2 theta over cos squared theta will be equal to 0, right, which would result in this left-hand side, right, having a division by 0 if this expression is equal to 0. So let us see. So in this case, we're saying, well, we're looking for where cos theta is equal to 0, right? And like I said, if we look at the cos graph, right, where does this occur? This is 90 degrees, this is 270 degrees, this is 450 degrees, this is minus 90 degrees. So pretty much the solution here is theta is 90 degrees plus K180, right? So that's the one set of solutions. We'll come back to this situation where we need to write it as one single statement. Right, so then the second case we're looking at is where is sine 2 theta equal to 0. So sine 2 theta, this 2 is causing our sine theta graph to compress horizontally, right? So it's going to look like this. Wow, that is a very character-filled sine graph. Okay, so this will be 0. In the normal sine graph, this would be 180, but because things are happening twice as quickly, this is 90. And this would have normally been 360, but now it will be half of 360, it will be 180. And we can see the pattern now. It's every 90 degrees we have an x-intercept, right? And this will be minus 90 and so on and so on. So what is the expression that encapsulates all of this? This is simply all the multiples of 90, right? So this is 90k. Okay, 90, let's be consistent. Right, so now we want to combine these two, right? And we can see that actually this one is a superset of these solutions, right? This is just 90, and then we skip the 180, and then 270, and then we skip the 360, and then 450, right? Whereas this one is every single multiple of 90. So this is actually the solution that contains this one. So we don't have to have this and this. This also covers this one. So the finale solution will be theta is any multiple of 90, which makes sense, right? Because we know that tan is not defined. Well, okay, yeah, it's a bit more specific than if we look at the normal tan graph. It has its asymptotes at 90 and then 270 and then, right? So it pretty much follows this pattern, right? It's not defined for these values. But in this identity, we're not only dealing with tan theta, right? We're also dealing with tan of 2 theta, where everything is happening twice as quickly. So the asymptotes are a bit more frequent. Hey, I'm not sure about this approach of mine. Okay, so I want to look at approach number 2. And then I'll come back and figure out whether this was solid. Okay, so approach number 2 would be to take this same expression, well, no, this expression, right? And let me see if I can actually take it. Oh, guys, conspiracies against me. Copy. Okay, so let's try it again with, okay, the picture came along. Let's see if I can get rid of it. Oh, I don't think I can. Oh my goodness. Okay, I'm just going to write it out. It's fine. So the denominator was tan of 2 theta times 1 minus tan squared theta. Okay, let me see if I got that right. Okay, yes. So the identity will not be valid 2 cases. The case where tan itself is not defined, and also the case where this denominator is equal to 0, because then we will be dividing by 0, which is a no-no. So let's start with the case of tan being undefined. Okay, and then we'll look at case 2, which is expression being equal to 0. Right, so tan we're going to look at in 2 parts, because like I said, we have tan of 2 theta, which behaves a bit differently to tan of theta. So tan theta is undefined when theta is 90 degrees plus however many periods, right? So this is if you look at your normal tan graph, right? You have these asymptotes that are occurring at minus 90, 90, and then you have the curve again, and then at 270 you have another asymptote, right? So that's 90 degrees plus a period plus another period plus another period, or minus a period, and so on, right? And then where is tan of 2 theta undefined? So the 2 is going to compress the graph, right? So instead of having a period of 180, it's going to have a period of 90. So our 0 point will still be the same, but now our asymptotes will occur at 45 and minus 45, right? And then this asymptote will occur at 135 degrees, right? 90 degrees later. And the next asymptote would be 135 plus 90, 225, and so it goes. So it will be undefined when theta is 45 degrees plus k 90, right? And this makes sense because if we take this 45 and we put it in here, right, 2 times 45 is 90, tan of 90 is undefined. If we take this 135 and we put it in here, so 2 times 135 is 270, and if you look at your original graph, right, tan of 270 is in fact undefined. Okay, so this makes sense to me, right? So we now have two scenarios, right? We have the two tans being undefined, A when theta is 90 plus k 180, and B when theta is 45 plus k 90. So if we kind of list the values out, because I'm not entirely sure how to put that into one, we've got 45 from the bottom graph, and then 90 from the top graph, and then 135 from the bottom graph, and then 225 again from the bottom graph, and then 270 from the top graph. Okay, so what's happening here? It was like we were adding 45, and then we added 90, and then we added 45 again. So here we kind of skipped 180, and vele 180 is not an asymptote for either of these. Anyway, okay, so I'm not going to stress too much about that for now, but just keep in mind that that's what's going on. Right, so now we're going to look at the case where this expression is equal to 0. So the only way that tan 2 theta times 1 minus tan squared theta is equal to 0 is if either tan 2 theta is equal to 0 or 1 minus tan squared theta is equal to 0. And that would be okay. So if we look again at the graph of tan 2 theta, we're looking at the x-intercepts. That's where tan 2 theta is equal to 0. So where are these x-intercepts? So first one is at 0. Well, not first. Obviously, this thing goes on infinitely in both directions. Next one is 90. Next one is 180. Okay, so it's the multiples of 90. Right, so either theta is k times 90, okay, right, or we need tan squared theta to be equal to 1. So tan theta needs to be equal to 1, really. And where does that occur? Well, we know that tan theta is equal to 1 either with 45 degrees plus k, well, yeah, that covers both quadrants actually. So it will be theta equal to 45 plus k 180. Right, and these solutions are really similar to what's going on down here, right, where we have the multiples of 90, and actually that will fill in the 180, right? So even though the 180 tan tan 2 theta will be defined at theta 180, and tan theta is defined at 180, right? But if we are to put a 180 into this expression, then this is going to evaluate to 0. Tan of 360 is 0. So then we would be dividing by 0, and that would make the identity invalid. So yeah, I was panicking about, whoa, it skipped a 180. It's gonna ruin. How am I going to put this into a single statement? Well, this condition might have skipped the 180, but the 180 is captured in this condition where we don't want the expression to equal 0. Okay, so we are in fact dealing with seemingly the multiples of 45, right? Yeah. So let me actually just write this all. Ooh, this is making me dizzy, and I have a feeling that I'm complicating something that shouldn't be complicated, but anyway, for the sake of completeness. So we have theta is 90 degrees plus k 180, right? That's coming from here. We have theta is equal to 45 degrees plus k 90, right? Which is coming from here. We have theta is equal to k 90, which is coming from here. And then lastly, we have theta is 45 degrees plus k 180, which is coming from here. Right, so we now need to not reduce this, terrible word to use in the context of trig, but we need to write this all as a single statement. I mean, this is a single statement, but it's kind of 4 statements joined into one. Anyway, so we need to figure out, well, which statement kind of swallows the other. So 45 degrees is half of 90, right? So what I'm noticing is that, well, 45 plus k 90 is going to touch every other multiple of 45, right? So the multiples of 45 are, and I'm just going to focus on the positive numbers, but you can easily extend it to the negatives. All right, so I'll just write the first few. Right, so 45 plus k 90 is going to touch 45 plus 90 plus 90 plus 90, right? It touches every other multiple of 45. Then the k times 90 is going to touch the multiples of 90, which are the multiples of 45 that the previous statement did not touch, right? So we're going to touch with 90, 180, 270. So these two statements together, we can collapse into one. The 90 plus k 180, well, 90 is a multiple of 45, 180 is a multiple of 45. So they are not going to bring up different numbers to what we're already covering here. And similar reasoning here. 45 is obviously a multiple of 45, 180 is a multiple of 45. So this is also not going to bring up any new numbers to what is in this sequence of numbers. So we can summarize all those 4 solutions in one solution that says theta is simply any multiple of 45 degrees. For any multiple of 45, the identity will not be defined. Right, and that will happen in one of 2 ways, just to really belabor the point. So it's either there will be an asymptote for that multiple of 45. So if you think about a number like 90, if we use 90, this will not be defined, this will not be defined. If we use 45, this will not be defined because 2 times 45 is 90. If we use 180, so 100, let's say tan of 180 is 0. So this would be 1 minus 0, which is all good and well. But then 2 times 180 is 360, and tan of 360 is 0. So you would have 0 times 1, so you would be dividing by 0, which would make this whole identity invalid. So for any multiple of 45, this thing will be invalid. I am not going to. Alright, but please let me know if that is clear enough. And so the key thing with this question was to recognize, well, okay, in what ways could this expression become undefined? And that is 2 ways. It's looking at, well, tan could be undefined, or we could find ourselves dividing by 0, and we need to avoid that situation or figure out how that situation would arise. So now going back to my initial thinking, where I decided that I'm just going to look at this in terms of sine and cos, right? So the idea was that, well, we found that this expression is the same as this expression, and so I looked at 2 cases. I looked at the case where this is 0, therefore making this fraction 0, therefore making this 0, therefore making our division in the original identity a division by 0, making it invalid. So that was the first case, well, second case. And then the other case was, well, where is this equal to 0? Because if this is equal to 0, then this fraction becomes undefined, this expression is undefined, the identity is undefined. So those are the 2 cases I looked at. And for that first case, I got the 90, 270, 450, etc. So 90 plus k 180, yeah. Then the second one, sine of 2 theta. So I looked at where it's equal to 0, and that just gave me 0, 90, 180. So yeah, using this approach, I didn't get the 45 degrees. I only got the multiples of 90. So this was actually incorrect. I would like to know why though. Doesn't cover all cases. I am very curious about why that is the case, why that didn't work, why that didn't give us all the solutions. I cannot immediately say why. I cannot immediately see why. So I'm going to rest it here, and if I have any bright ideas in the middle of the night, I will definitely record a follow-up video and share my thoughts. And of course, if you can see why this approach was inadequate, please drop a comment, and yeah, catch you another time for another ramble. Hello. Yes, okay, thought some more, looked at the memo, because why on earth am I closing the video without checking the memo? To make sure I gave the right answer in the video. So the good news is, yes, we did arrive at the right answer, but looking at how they went about the solution also helped me see why this first approach that I took was inadequate. And they raised the important point that in as much as, yes, this expression simplifies to this, we have to remember that to get here, we did a bit of cancelling, right? So we started here And we ended up with sine 2 theta divided by cos 2 theta times cos 2 theta divided by cos squared theta is equal to that. And this statement can only be true if this isn't 0, right? Otherwise, if this was 0, we wouldn't have been able to do this cancellation. So in order to figure out when this is undefined, we would have to look at 3 things actually. It's 3 cases. We're looking at the case where this is 0, because then this would be 0, and then we'd be dividing by 0 in the original identity. We're looking at the case where this is 0, because then this fraction is a division by 0, which will make this undefined. And then thirdly, we're looking at where this is 0 as well, because then this again would be a division by 0, and we would end up with undefined for this expression. So in order for this approach to get you to arrive at the right answer, you would have had to add a third case where, and I'll just do this in a different color, you'd have to consider the case where cos 2 theta is equal to 0, because then again this expression would have become undefined. So cos 2 theta equal to 0, well, we need to imagine our cos graph squished, right? So something like that, right? So instead of this x-intercept happening at 90, it would now happen at 45. This one used to happen at 270, but will now happen at 135, and so on. So you would have 45 degrees plus k 180, which is the new period. And so that is where now you would start getting the multiples of 45. Oh, it wouldn't even be 180, sorry. It would be plus 90, because in the original cos graph, your x-intercepts are 180 degrees apart. So in the cos 2 theta graph, it makes sense that your x-intercepts will be 90 degrees apart. So this solution actually would have given you all the solutions, because it would cover these solutions, right? Again, 90 and 180 are multiples of 45, so these would be a subset of these guys. And similarly, 90 and 90k are all multiples of 45, so this solution, oh, okay, no. I think I just need to terminate for the night. I think it's time to power down. Okay, right, let's speak sense. Let us speak the truth now. So 45 plus k90 would touch alternative multiples of 45, right? Because it would be 45, 135, 135 plus 90 is 225, right? So it's skipping all the, it skipped 90, it skipped 180, it's going to skip 270 and go to 315, right? So this solution here would touch every second multiple of 45. And then what would fill in the gaps? Well, the previous solution that we found, right? So that would be your 90s, 180, 270, 360. That would be every other multiple of 45. And so using this guy and this guy, which comes from these two, we would then have the multiples of 45 as the final solution, which is also what we found with our more involved approach. So yeah, like I said, as I was originally ending the video, the key thing with this question was to recognize that tan itself is undefined at certain points, and thinking about the fact that when you have a division, you have to be careful about situations where you might end up dividing by 0. That is what would yield the angles where the identity is undefined. Whew. My jaws, my eyes, my head, my eye socket, everything is just throbbing. Guys, thank you for tuning in, and yeah, I find myself repeating and overcompensatingly repeating stuff, because it is my earnest hope that these videos can help someone just better understand something that might have felt a bit foreign in class. Cool. Catch you another time for reals. Your calculator.